If you've seen the Kubota garden tractor restoration on my channel, you'll know that started with me using the tractor. The water pump had a leak in it. I pulled it in the garage. The next thing you know, I've got it ripped apart, and that turns into an over 2-year restoration. This is the same situation. We had a really hard freeze coupled with the structure that covers the pump and the two pumps was falling apart. And so my normal heat lamp and blanket protection didn't work. So I had a pipe crack. And so to get to the cracked pipe, I had to take some of the building apart. And once I started taking it apart, I just kept taking stuff apart. And it led to me completely redoing the configuration and doing some updates and maintenance on everything. So that's where we're going to start, is where I'm beginning to take the structure apart. Okay, that's what I've taken off so far. And if you look, you can just tell that it's been slowly collapsing, and you just keep piling crap on top to try to reinforce it. But the time has definitely come, and I'm pretty sure I'm going to be able to completely redesign this to make it a lot smaller footprint. So we'll continue taking stuff off. All right, this entire enclosure was framed, but then built out of this hardy plank. I don't need you. It's a good material because it never rots or anything. The problem is it's like building this thing out of dinner plates. It's so fragile. You know, I think that hole down there was a rock. Mower kicked, it was a big rock. It bent the blade, but still a rock hit it. And then you can see through the years, the edge has gotten chewed up. I'm not quite sure what did that. Maybe weed. I don't know. But yeah, as much as the indestructible part appeals to me, the whole glass jaw crap is just, I don't want to go back with this unless I have to, which I don't have to unless I somehow decide that makes the most sense, but I don't think I will. And I'll have to do this into pieces that I can easily dispose of in the garbage can, so. So you get the idea. I'm gonna keep doing that till we got this thing down to its frame, and then we're gonna assess what makes the most sense as far as rebuilding this. All right, this system is used solely to fill up this tank for irrigation. It's not for any city use, potable water or whatever, all right? So all the well does is pump water into this tank. That's it. So it comes out of the well this way, through the pressure switch, expansion tank, got a faucet, I guess. I'm not sure, I guess that's a open and close valve, gate valve. I'm not sure what that's for. Then it goes in here and it goes up and just dumps into the top of the tank, all right? Now the irrigation system comes out, goes through this pump, goes, you can see it just runs off to the sprinkler system. So knowing that all this well pump does is ever just pump straight in the tank, one, I don't think I need this pressure switch. So I'm thinking I could run power straight to the pump saver. And then two, I can come from this well through this pipe straight into the tank. Now I would let's see. Yeah, I would probably just go from here, run parallel to this thing, and they would join together and then go up. Because it's a very low producing well, so it just runs all the time. It'll turn on, it runs for about a minute, and then the pump, and then it runs out of water. Pump saver kicks on, kills it for 30 minutes or 45 minutes, whatever it's set for. Then it comes back on. So there's nothing that turns it off when the tank gets full. When the tank gets full, it just starts spilling out the top. But I only use this thing in the summer for the sprinkler system, and in the summer, the tank never gets full. There's no need for it to be able to sense whether or not the tank's full and turn off, because it doesn't now, and that just really doesn't happen. So this is where you can see probably this is all cracked right here. So I could cut this out and replace it and be done, but I mean, while I'm in here jacking around, I want to do it right. So okay. So this might be good. So I'm going to cut right here. Now I can move this assembly. Isn't in my way. Make sure the O-ring is still on there. Wow, look at all the calcium, whatever you want to call it. I left this in case I want to reuse this, because I don't know where it's bad. That's cracked, so probably go right here. I'll leave it where I could reuse this tee. See, if you leave this much, you can put a coupler on here so you can reuse these. So that is this. I do that too. All right, so now I should be able to get rid of this stupid thing because I don't need it. Hopefully it doesn't weigh 1,000 pounds, and no, it does not. There's no snakes under there, which is even better. So initially in my plans, I was going to put this slip joint like right in here somewhere, but it looks like it might fit right there. Let's see. Yeah, it'll fit there, but wow, that is, you know what? So I could, if I cut it perfectly and clean it up real good, I could get it there, but I'm not gonna do that. I'm gonna put it over here where I originally planned, because this gives me a lot more screw up room. And honestly, if you back up and look, the whole point is so you can take the pump out. Whether I break the line here or here, what does it matter? I mean, in the big scheme of things, if I'm gonna take the pump out, it's not, neither one of those is gonna make it any easier, so. So I'm not gonna put it here, I'm gonna put it here. If something goes bad, that'll let me cut it, and I can still put something else on here without having to replace that. Now it doesn't really matter which way these things go, but I'm thinking about, so if I ever have to crawl in here and change this pump and this thing's tight, do I want to be loosening it pulling or pushing? And I'm thinking pulling is the way I want to loosen it. So that means I'm going to put it on this way instead of this way, because if I put it on this way, I'd be pushing it to loosen it. This way, I'm pulling it to loosen it. And see, if I do all that planning ahead, that means I'll never have to replace the pump. And then, you know, like why you see me slop that on there, like here in Texas, like if it's residential plumbing, which this isn't, but the inspector comes, if they want to know that you've primed it, and so if they don't see that primer, sometimes they'll fail it. So alright, so what I'm going to do is I'm going to have this. It's a pressure gauge. So this will be sitting so I can look at it from out there. Then we'll have this, which is the pressure relief valve. Then we'll have this, which will be a low point drain, which I'm probably going to point to the inside. Then it'll just go out. So let's put this together. And this is just basically liquid Teflon tape. Seems like just a light coating would be plenty. Alright, so that will go like this. Okay, and what this is a pressure relief valve. So it's not a reducing valve. Right now it's set to 75, but you're supposed to be able to adjust it up or down to a degree. So if it gets over 75, it releases water in here, and what we'll do is we'll plumb this water back into the tank. But right now this sprinkler system doesn't have one. I'm not sure why it doesn't. I'm not sure, because the problem is if you turn the sprinklers on, your heads are open, so it's okay. But if you have a head or a circuit fail and this pump's just sitting there pumping with no place for the water to go, these things will create some pressure. So I'm worried about blowing out a line. So while I've got it all apart, it's standard practice with an irrigation pump like this to have a relief valve or some way for pressure to relieve itself. So we're going to add this in there. Got my hammer.
All right, so we got the water coming in, goes through a check valve so the water can't come back through from the pump. Here, it's the pressure gauge, pressure relief valve, so we can use this to adjust the pressure and watch it here. This is just a low point drain. This will always be closed unless we're draining the system. Then it goes out to the to the sprinklers. So if we can put a coupler there, I think that's what we'll do, is we'll put a coupler there, then we'll cut this off right here. Oh yeah, that's perfect. We'll need to dig out some rock in here, dig some of this out, but yeah, I'm gonna have to cut some off of that pipe. Now I'm gonna let that sit, since we do have a little gap here, which I can pull it together, but now I can fix it. What I can do is let this dry. I can cut it right here, put another coupler in there, glue it on one side, and then jam this in there, put it down, tighten it, and then let it dry where it dries. So I'll probably do that. It's the next day, and so where we left off, what I need to do is, you can see there's a gap in this. So what I'm going to do is I'm going to cut this, put a coupler on there, I'll glue it on one side, and then we'll slide it on with glue and then pull this back over and make up the difference. So I don't know if that made sense, but there, I can feel it hitting the ridge. I just want to hold it. A little bit more. Here we go. So now the sprinkler system's done. Let's work on the well. All right, so okay, so we'll have this, but this is going to go here like that. All right, and then this will go down and go over into that. And so what that is that's the overflow. And so if it does overflow, it'll just pump it into here, which will go into the tank. Now, and I know I'm putting another T right here because that is going to be the low point drain for this fill pipe. And I angled it just a hair down. You can't really tell, but I did. The purpose of this is so if the sprinkler system gets overpressured, that valve right there, that will open and it'll relieve the pressure, so it's going to let water out. So when it's letting water out, where do we want that water to go? Well, what it's going to do is just run back into the tank. It'll use the same pipe that the well uses to get water into the tank. The one problem, or the one thing we have to be careful of, is we don't, when the well comes on, we don't want the water to come down and try to get in here. That's what this is for. The water will come in from the well and go down and can't get in, so it'll just keep going. But if the water comes in from there, it'll come up and open up that valve. Okay, we want a little bit of an uphill. There we go, about like that. Just so when I drain this thing, it'll drain downhill. Now, this is the pressure valve for the well pump. So the way that works is when the well pump's running, once the pressure drops below, it turns on. Now, the issue is this switch should never be used because this system doesn't build any pressure. It's just pumping into a tank. So I was going to take it off, but I've already got it, so I decided to leave it on because the one time that this would be handy is if I left the well on, right, and somewhere in this line, anywhere here, maybe it freezes or gets clogged. So the well's pumping and it can't move the water, this switch will turn it off. Just hold this for a while. And I'm putting this cutoff here just in case this little overflow valve gives me problems, like it's leaking or something. I can just disable it with this. If everything works right, this will never be, you'll never have to shut that, but just in case. So you can see it's a kind of angle, I don't know if you can tell, but this comes down and it's kind of at an angle like this. And so that'll be if I ever need to drain this, you know, if I turn the pump off and I want to drain this line so it doesn't freeze, I can just open it. You only got one chance at this, so. So as a recap, as far as the irrigation goes, water comes out of here, that's from the well. It can't go down because it's a check valve. It won't let water go that way, so it keeps on going this way. That's closed. Goes through the pressure switch, up, and into the tank. So the irrigation, water goes through here, into the pump, through here, through a check valve that only lets it go this way. That's so it didn't have to fill up the system again. Comes through there, pressure gauge, overflow valve, and so this is set to 75 psi, so and it keeps going out to the sprinkler system, right? And this is a low point drain. And then any pressure over 75 psi will bleed off into here, up, it'll push this valve open into here, and pump it back into the tank. So as far as the pump and the irrigation system, we're finished. But there's one more thing I'm going to do that I had wired up that y'all haven't seen. So what that pipe is right here, this is city water. Now what I had is a connection. Anyway, I've had a pipe that comes into that pipe right there. And what that pipe does, it goes up and it comes down, and about right here, which I'll probably pull it out and show you, right here is a valve, and think of it, it's a big valve about this big, but think of it just like a float in a toilet. What that's for is, since this is a low producing well and there is an opportunity for me to drain this tank and run it dry when I'm running the irrigation system, what that valve is for is if once the water gets down to this level right here, that valve opens up and starts putting city water into this tank, just so this pump doesn't run dry. I'm also going to run a wire down here and connect it to my sprinkler system. And so instead of that emergency water fill thing being on all the time and I'm just relying on this float, I'm going to put a sprinkler valve, so that supplemental water will only be pressurized when the sprinkler system's running. So in that case, if I get a leak in that valve, it won't sit there and just run 24/7. Maybe a little too much there. There we go. We got everything hooked up. So it's the next morning in this hole where y'all can see when I turn on the pump. All right, I'm gonna go turn on the pump. Hopefully y'all can see it. The check valve is working. Pump water's coming, tries to go in there and it can't, so it can't come out, so it keeps going down. So we got a leak right here. This is for that supplemental tank fill that goes to that basically cattle trough valve that you see way up there at the top. That's down inside the tank. All right, so water will be coming in from the city to a shutoff. All right, here's the valve, sprinkler valve, that will open when the sprinkler system's on. So basically this supplemental water thing will only be available when the sprinkler system's actually running. All right, but in case this doesn't work or locks up or freezes, I want to have a way to bypass it. So we're going to put a T here, T here, and actually think of it more as like this as far as elevation goes. And so we'll have a T coming down to a 90 like this, to a T, so for whatever reason I say I don't care about this valve, I want this thing to be pressurized all the time. I can open this and then basically just this valve is irrelevant at that point. Normally this would stay closed, right? But I just want to have the ability to bypass this if I need to. This right here is once again a low point drain, and this will be a low point drain for that entire circuit. So it comes down, and all that valve razzmatazz is going to go in here. So the well circuit's good to go. Okay, you're getting ready to watch 2 days condensed down to about 2 minutes. You see that path on the screen there? That's the distance from where the sub panel is and the sprinkler controller all the way up to that tank. And when they were doing construction work for septic system, I had laid conduit from that sub panel all the way to the tank. But I think it got creased, or I know it got creased because I can't pull through it. So you're going to watch me struggle. I was able to get kite string through it. I used twine, that worked, but I couldn't pull any cable. I tried the 250-pound plastic stuff that you use for normal, household or residential cable pulls. I switched to the 1,800-pound pull tape. That broke. There's such a crease in there somewhere that I had my wife on the tractor trying to pull this stuff through. It was spinning the back tires on the tractor. Once I put the tractor in four-wheel drive, it just kept snapping that 1,800-pound stuff over. So you'll see this struggle. I am able to ultimately get the sprinkler wire down there. All right, let's try this. Whew. I don't think so. Oh, well, look at this. Well, I started pulling it and the string snapped, so, so it can't, there's obviously a crease, or there's something, because literally all I was doing was just pulling kite string through the pipe. It hadn't even started pulling the other rope in yet. So there's obviously a real tight bend somewhere. Come on. Aha. All right, so what I'm going to try to do is pull this tape through. So this plastic stuff is 250 pounds, I think, test strength. This is 1800, and this is what this is actually made for. So I got some cable lube. I'm going to save most of this for the actual cable, but I'd figure if this rope pulls some of that stuff through, pre-coats it, it'll help. All right, so that's the setup now. So we'll go up there and see if we can pull from this direction. I'm kind of losing hope, but let's find out. Keep going. All right, go. So this is the wire that we ran through the conduit, and it's going to run up to the sprinkler controller. And the purpose of this wire will be to open this valve. And then what this valve does is it goes inside the tank, and it's on a float valve. And this is city water, so the float valve's near the bottom of the tank. So usually when the sprinkler system's running, it'll be running off of the well water. But if it pulls the tank down and it's getting close to running dry, so we'll run the irrigation pump dry, the water will fall below the level of that float, and then it'll start letting city water into the tank, so the irrigation system doesn't run dry when it's running. Now, the purpose of this valve is so that float valve isn't pressurized all the time, and it's only pressurized when the system's running. The reason I'm doing that is because this is a huge tank. So if that float valve gets just a little leak in it, it could sit there and just be pumping city water in that tank all the time, and that would lead to a tremendously expensive water bill, which I don't want. And you can see that's in case I ever have a problem with this valve. That's what this is for. This is just a bypass. So if I open this, then water will go straight to the float valve. And this is just a low point drain for this contraption. All right, glue's melted, solder's melted, we're good. Okay, so that's the wire that's gonna power this up. It's about right there. There we go. So we want this valve to open whenever the system's running. And so the way we do that is tie it to this line right here, because this opens, or this turns on the irrigation pump. Alright. Alright, so we should be done. All right, so what we're going to do is we're going to basically turn on the sprinkler system. Now, it's going to send a signal to open this valve and turn on that pump, but I've got the breaker for the pump flipped off, so the only thing should happen is this valve should open and water should start flowing. So, front yard, let's just do it. Water for 1 minute, so. Okay, I went and reversed the wires and tightened up the connections, and it's on right now, and now it's not buzzing. So that was the issue. So thank goodness I don't have to replace the solenoid. All right, see ya. I got some Henry's Durabright white roof coating. I'm gonna give that a shot. See if this worked. It's been wrapped up for like a week. So the old wrapping it in saran wrap trick seems to work. All right, this stuff seems to spread pretty good. This is Henry's roof sealant, and I'm using it to basically try to waterproof the bottom 4 or 5 inches of this siding. It's supposed to be water resistant, but it's not rated for ground contact, which it's going to be ground contact, although it's really sandy soil, so it's not as bad as it could be. It really drains. All right, I'm not recording much. I can just show what I've done so far. So I reinforced the frame. I added these two here because I'm going to put a, not a gate, a door right here. I've already framed in over here. There's a door right there that'll open up. There's one right there, and there'll be one right here. So I'll have 3 ways of getting in here. You can see I cut out for the pipe down there, and I'm going to fill that up with expanding foam. Now all these boards touching the ground have been touching the ground for 20 years. So there must be some kind of pressure treated before people cared about cancer or whatever. So I just left it. So I'm just roughing it in right now. I got to put this panel on and cut this out, and then I'll take them off and paint them and stick them back on there. Okay, it's been another day of working out here. Can't tell much, but I got all the siding cut and fitted, foamed in, and I rewired the pump. Put little thresholds here or whatever. So See you tomorrow. So this is going to be a brace, and it's going to go underneath those rafters or whatever. What I'm going to do, I'm going to have a 2x4 going down to the ground to a concrete 12x12. And then I'm going to put these little braces on it like this and give them a little bit of room. Like that. So that way it'll be captured. And you know, this is, you're looking at it upside down. This will be going up till it hits the ground. But that way, if I'm ever there working, I got to replace the sprinkler pump or something, and this freaking support's in my way, I can kick that cement block out, and this will just pull out. It's on the post. And to get it out, all you got to do is kick it. But it'll stay there as far as stability goes until you remove it. All right, here, give it to me now. Pull that off.
Like that?
Yeah.
Yeah.
All right, keep going around. We're trying to make it so the water will run off.
Run off and not.
So you want it like at an angle down, you know what I'm saying? There you go. All right, after I finished sealing up that pipe, I painted the roof with that Henry sealant to act as another water barrier. I put in 2 vents. I painted it. After painting it, I had shingles left over sitting in my shed, so I watched a video on YouTube, shingled the roof of this thing. I know the angle's not correct, but it's what I had laying around, so. Well, here's the finished product. Finished it about a week ago. So you can see I've got a door on this side. This is just a panel. If I need to get in there, I can remove this panel. And then I put a door on this side. So I don't think I'd ever use this panel. That would be like if I'm really in there, like replacing a pump, or I need light and a bunch of space. But that's city water. It's on the same line that feeds that auxiliary fill system for the tank. If the sprinkler system's running and the tank runs out of water, or it gets pretty much down to like this level, there's a float inside of there, and it opens up the float, and then city water starts coming out. And this is an overflow line. If it fills the tank up, it just pours out the top, but I went and sealed that up and put this hose or this pipe, so instead of dumping water down the front of the tank and back in here, it'll push it out here, and then so it won't erode under the tank and everything. But if you got questions about any of this stuff, just ask me. But hope this helps. See ya.